All right. Our next friend, he's ready. Jeff Zuerlein.
Zuerlein.
Zuerlein. Jeff Zuerlein. Welcome, Jeff Zuerlein.
Thanks. So we spend weeks writing software, but then we test it with maybe, 4, maybe 5 rows of data. And I've done it, I'm sure some of you have done it. It doesn't feel great. It feels like you're gonna throw a Hail Mary pass at the end of a football game. So today, I'm gonna talk about generating lots and lots of test data really fast. We're not gonna use any third-party software, just a little bit of T-SQL know-how. Because if you test your software with a few thousand rows, you don't really know how it's going to perform with a volume of data. But if you throw millions of rows at it, well then the problems are just gonna sprout out and they're gonna smack you in the face. And we like that. We want to fail fast. We want it to help us identify problems. Problems like, am I fetching more data than I need to? Or maybe I've got a CPU-intensive operation in the middle of a data access function. Maybe there's an inefficient query, it needs a little bit of tuning. Or maybe it's something easy. Maybe I'm just missing an index and I can just add an index. Or maybe you're not so lucky. Maybe you've chosen an algorithm or a process that just doesn't work so well with a large amount of data. So you want to identify these things quickly. Now a lot of people will ask, well, how much data do I need to do the testing? And I usually say, well, take a look at your production system. How much data do you have in production? Use that as a guide, but then project out a year or 2 or 3, because you want to be testing with enough data to ensure that your software will work well now, as well as in the foreseeable future. So let's take a look at a real simple example, the simplest thing I can think of. Let's just create a table of integers. And the simplest thing I can think of, just insert a row and put that in a loop. And just do that 10 million times, right? Let it crank. And actually, this will do pretty well. It'll run in about 2 to 3 minutes at least on my hardware. But we could do better. We can do better because SQL loves set-based operations. And so we want to minimize the number of iterations, and we want to maximize the number of rows that we operate on in each iteration. And we can do this by selecting all of the rows in the table and inserting those in each iteration. So we're gonna double the number of rows every time we iterate through there. So we're gonna get 1 and then 2 and 4 and 8, 16. You guys all know this sequence, right? Right, we're gonna generate those things really fast. In fact, it's gonna go down to 16 seconds, and that's a great performance increase. But some of you might be saying, so what? You just added a table of numbers. What am I gonna do with that? How can I test that? Well, actually, that table of numbers is magic, because that lets you perform one SQL insert operation to add all 10 million rows. Now, in this case, we've got a customer table with a first name and a last name, and granted, our first names are going to be like 1 underscore first name, 2 underscore first name, 3 underscore, right? It's not going to look realistic, but still, that's going to get generated in 19 seconds. That's awesome. But we can do better. Because what if we had a list of names? And we can get a list of names. We can go out to cms.gov and we can download the NPPES database. It's a list of about 280,000 physicians. And they all have names. So we can go ahead and extract those first names and extract those last names and use those to generate realistic test data. So let's imagine we can take our numbers table and we can take those names table and we can join them together in one SQL operation, so it's going to be fast. In fact, 17 seconds and I can generate 10 million rows of realistic test data. This is great. Now, some of you, if you're familiar with SQL, you might be thinking, wait a minute. He's got 10 million rows over here and he's going to do an inner join with these 280,000 rows. He's not getting 10 million rows. He's going to get 280,000 rows. Well, take a little bit of a look at that inner join. Oh, now I did it. Oh, bummer. All right, I'll keep going. So what's going to happen is we're going to use a little bit of modulo magic, thank you, in order to reuse those names that are in the names table. So instead of joining, like for example, if we have 5 rows in our names table, instead of joining row 6 to row 6 over on the names table that doesn't exist, we can use 6 modulo 5, because there's 5 rows in the names table, and we'll get 1. So it'll go back to row 1. So we can reuse those names over and over as we go. All right, so this has just been a quick little example of how you can generate some test data, but don't stop there, because you can use this same technique to generate parent and child tables or hierarchies. There's all kinds of options available. You could use AI to go ahead and generate some realistic test data, or heck, you could use AI to just generate these scripts. So the thought that I would leave you with is, failing a production is expensive. It hurts. But failing a test, that's a gift. So I hope you'll go back and think about how you can generate your own test data and improve your own software development process. Now I went through this really fast, so I actually have a YouTube video, and if you search for my last name, which is pretty damn unique, you'll be able to find it and rewatch it if you like. Thank you all for listening.
Thank you, friend Jeff. And I hope Ava was paying attention, because now there is a way to test all those 10 million eyeballs that aren't going right with the Unicode. If I got that right, but I'm not very technical, so I don't know what I'm talking about.